Oh, that's my favorite thing. So, 6.4, once again, we started this on Friday. We said, hey, in this example 1, we had Jenna deciding between 2 cell phone plans. We said the first plan has a $50 sign-up fee, costs $75. It was 80, we switched to 75. Second plan, $30 sign-up fee, $80 per month. Was 75, we switched to 80. After how many months will the total cost be the same, and what will that cost be? So then we said, okay, how many equations do we have here? We have 2. Let's see, unless the reason on after us we forget. How do we know we have 2? Well, you can see 2 different parts in here, 2 plans. That might be a giveaway, first plan, second plan. Another thing that we might have there is the fact that, hey, what have we been doing this entire chapter? Solving sets of how many equations? 2. Sets of 2 equations all the time. So we're probably going to continue to do that. So then we said, okay, we set it up to where y was our total cost. We had it equal to 50 the sign-up fee plus $75 per month, x. And the same thing the next one, y being the total cost, $30 sign-up fee plus $8 per month, 80x. X being the months. So we chose to solve it by substitution, or did we choose to solve it by elimination this class? You guys have it in your notes. Which method did we choose?
Substitution.
We did substitution, okay. So we chose to solve it by substitution, which is what's on here. We have everything equal to a variable. When everything's equal to a variable, substitution is going to be a very good choice. When everything's equal to a variable, substitution can be a very good choice. But this one's also already set up for elimination as well, because you can just add them vertically after making one of them negative. So it really could work either way. When we say graphing might not be the best idea on this one, why? There's no graph. And if we do a hand-drawn graph, will it be as accurate? No, it's a little bit harder to tell where they intersect on a hand-drawn graph. Because remember doing the warm-up in here where we had a hand-drawn graph, and it didn't, and all of us got a little bit different answers. That's kind of helps us to see, oh, maybe it's not always the best idea, but if we have a graph, it can be helpful. So, let's go on to number 2. So in number 2 here, one cable TV provider has a $60 setup fee and $80 per month. The second has a $160 equipment fee and costs $70 per month. In how many months will the cost be the same, and what will that cost be? What's going to be our first step here? Right? So setting up equations and figuring out what's in the equations. Okay, how many equations are we going to have? 2. How do we know we're going to have 2 equations?
There's 2 different bills.
There's 2 different cable providers, right? We're comparing 2 providers. Comparing 2 different things. They're both dealing with cable, but they're 2 different providers. Also, how many equations have we been working on in this chapter? 2. So that might be a hint that we need 2 equations. Can somebody help me with the first equation? Raise your hand if you can help me with this first equation here. Grace.
80x. Would it be y equals 80x?
You can have it set up however you want. So that could be one way to set it up.
80x plus 60 equals y.
There you go. That could be one very good setup. So what I want Josh explain what this 80 is. The cost per month. So what's x? The number of months. Very good. William, can you explain to me what 60 is? The setup fee. Are we going to have to pay a setup fee every month? Oh, I sure hope not. If we do, then I'm going to be calling them up and complaining because I will be one unhappy customer. And then what's this y going to be, Derek? What's that mean? What all comes together to equal. So what would that be in this case? It does all come together to equal that. But for this problem, what are we dealing with? Are we dealing with like a total number of kangaroos? Money. We're talking about the total cost, right? The total cost we have to pay for this company for however many months. Exactly right. Okay, raise your hand if you can help me set up the second equation. Justin.
160 plus 70x equals y.
Okay, 160 plus 70x equals y. Hey, before we write this down, could we write this in a slightly reorganized way to make it more lined up if we wanted? Yeah, do we have to? Not necessarily. What were we saying?
It'll be easier because you won't get your numbers split.
It might be easier to knock our numbers flipped, but we don't have to. But I think we should, purely because we did the first one this way. I would vote for doing the second one this way as well. So Justin, go ahead and tell me what it would be if we were to change the order up just slightly. All the same numbers, all the correct math you had. Let's just change up the order to match it a little bit better.
70x plus 160 equals y.
70x plus 160 equals y. Once again, that wasn't necessary for us to do, but it might make it a little easier on us to stay organized. Ben, explain where the 70 comes from.
The one where it said
The 70 per month. So what's x? The number of months that you have the service. Okay. Kale, what's a 160? The setup fee, or in this case, the equipment fee, right? Are we gonna have to pay for that equipment fee every month? Once again, no. I sure hope not. If we do, once again, Mr. Cross is gonna be calling them up, complaining, and making sure I don't have to pay that every month. I will not be a happy customer. And what's this y, Blake? What's that y? The total cost, right, for that second plan. So, we have our two equations now. That's awesome. We got one equation from this first sentence, or one equation from the first half of the sentence, and the second one from where it says the second provider. In how many months will the cost be the same? What variable are we trying to solve for if we're trying to figure out how many months the cost will be the same?
X.
Y.
Ooh. How many months? Which one's months? X. So what variable are we going to be solving for with this part? X. Okay, let's look at the second question. What will that cost be? What variable do we need to solve for there? Y. So in the end, do we actually need to solve for both either way? Yeah, so does it matter which one we solve for first? No, it really doesn't, because we use one to find the other. Now, we have a few methods we could use. We have a few methods we could use to solve this one. Somebody tell me one method we could use. Justin.
Substitution.
Substitution is one method we could use. That's what we used in example 1. We could use that here as well. What's another example method we could use? Grading. Elimination. Okay, what's another method we could use if we had a graph? Graphing, right? Okay, but we don't have a graph, so it might not be a good idea. The class vote. Do we want to do elimination or substitution? Okay, so class vote, get your vote ready. Okay, substitution, elimination. Raise your hand for substitution. 1, 2, 3, 4, well over half. Okay, so we're gonna do substitution. So for substitution, is it already set up for it?
Yeah.
That's kind of nice. Okay, so how do we know it's set up for substitution? We have a variable by itself in at least one of the equations. For substitution, we need at least one variable by itself. We say it's by itself when it's the only thing on its equal sign. So in this first equation, we have y by itself. In the second equation, hey, we also have y by itself. Okay? Somebody describe to me what we do here now. We're doing substitution. Describe to me what we do. Great.
Substitute. Well, we'll do this. Substitute the top equation for that entire thing is going to be a y for the second equation.
This entire thing will be the y?
Like 70 equals y.
Oh, so the entire left side. So all of what y equals, we're saying is y, and that's what's going to go in for y here. Christian, help me write this new equation.
70x plus 160 equals 80x plus 60.
Very good. 70x plus 60, the left side stays unchanged in this bottom equation. And now instead of the y, we have 80x plus 60, what we're substituting in for it.
Do you have to put it in parentheses or do you just do that?
I do it every single time we substitute to get in the habit, and I recommend you do it as well, because whenever we have it where we're substituting in, like if we substitute it back in for the x, for example, it's easier to do the multiplication when you have the parentheses to remember it. So that's why I always do it, so that way I'm never out of the habit. But you don't have to, you wouldn't have to if it's on this side of the equal sign by itself, because you're not multiplying anything. Once again, I do it as a habit just to make sure I always do it. And that's what I recommend. Good question. Okay, what I want you guys to do is I want you guys to finish solving this for x and y. I want you guys to finish solving this one for x and y. I think so. I think it's fun. Sit down. I understand that.
Of course you do.
Okay.
do the thing while he's talking.
Yeah.
That's disrespectful.
Good to me. What is that hand?
Oh, you got that? Well, your brother? Oh, so the chicken was possible. Feisty post, that's probably why. You are? At 4,000. You get a foul, the other two get a foul.
I swear that sounded like it came from the S5.
I did tell you this. So you started more. I was like, I was there after 6 for no reason. It was just after he was running, just jumping. Now I felt more stupid. Just went out of bounds. I'm like, Lauren. That's funny. I can do the same stories from like, oh my god, the short with the curly hair. What? She did like 3 times. I didn't say that. She did like 3 times. I'm like, you know, push my team. I'm passionate, Lauren.
What's your favorite?
We raced. That's what I'm doing, push button. That's because I push it between the second baseman and the first baseman. The first baseman will come up, the pitcher will come up, so it's like this, and then the second baseman is going over to that. So if I hit it and hit it correctly, it'll go out of the I push button and it'll roll. And I can still It's my dad, I don't want to push it. You told him that. I did.
You marked me like right in the league.
No, I did. We're gonna have to pay like $1,000. Yeah, I know.
Their choice, and I've been money.
Well, I know, but I feel bad. Yeah, so I'm fancy fundraising.
She's 11.
She's 11.
I feel kind of sad because like she's 11, but she's like up to here on me.
No,
She's
lower.
so
Yeah, she's like.
she's really short, but like she can throw.
Yeah,
she
she
can
has an arm.
like she has an arm.
I'm
I'm just
pretty
like
sure she pitches too.
she does.
She does. She did.
She flies good.
She's gonna be a mini me.
In the batter box, we're gonna make her squat very good so the pitcher has like this much of a strike zone.
Remember when Hannah would do that? Okay, so Hannah Wellstead, she's already short, but when she would get in the batter's box, she would go like this. She would go like this, so that nobody could strike her out. And I'm like,
I wonder if you walk
That's the only reason why I'm taking calls, because my strike zone is more than my arm. So I'm just like, you know they're having me push butt? Yeah.
What?
But it's gonna suck because then I'm gonna get out a lot more. Only faster.
Guys, remember that one game where you ran to first place and you ran all the way through, you went to turn to second and you slipped and fell back to the first place?
No, okay, so, oh my god, I just blew my nose, and look how much makeup just went off of me.
Rip in the chat.
Yes, I will, man.
Crazy.
Okay, but you,
You ran through first, slipped, trying to go to second, then you
no,
fell
okay, so I
back.
ran through it, and then he goes, two, go two, and I slip, fall, and I have to get up and dive back to the back, because I was over the line. So there's like a line, you know, like that. And then, so when I turned, I was like over the line, so then like I fell, and then they were like running, so I go, yeet,
Then she stole second. Then she stole, this was a game where we were.
and then I stole second and third.
No, and home.
And
Yeah, because it was a game where we were tied in the tournament. It was my freshman state.
yeah,
Yeah, then she ran to second, and they overthrew. She ran to third, they overthrew, and she came home.
yeah, that's how we won the game. And I slipped so hard.
It's sad that the other 14 teams. Like, they lost their first game.
Yeah, we got second.
They wouldn't even go up.
Yeah, we did.
We got second, we would've got flat.
We did. Yes, we did. We got second.
Looking at you, Betsy.
Yeah, but you have the best.
Okay, but I'm so excited to push bump this year because then it goes because then I
So
can
class,
Christine, you're the two pitchers.
hey, I'm just gonna go ahead and discuss it up here right now, okay? Discuss it right up here right now. So a good math move might be for us to subtract 70x. We can solve this a couple different ways, but a good first math move might be to subtract 70x. You can get 160 is equal to 10x plus 60. Then we say, hey, we need to get these constants away from the x and all on the left side. So we could have 100 is equal to 10x. Now, 10 and x are doing what with each other?
Divided.
Multiplying, but we need to do division. So we divide both sides by 10. And we have x is equal to what number? 10. Are we done yet? No, what do we have to do? Plug it in. Into where? X in what?
One of the original.
In one of the original equations. Okay, do you guys have a preference? I heard second. Okay, why would you guys choose second? We could choose either. I think they're about equal. Okay, a little bit smaller number to multiply it with. Okay, that's fine by me. So we'll take this 70x plus 160, but instead of x, we're gonna put this 10 in. And remember, when I substitute, I always just put wherever the x is, I put it in parentheses. Yeah, that's what I was talking about. Is this right here? And so we rewrite the rest of the equation the same. So we say, okay, what is 70 times 10? 700. And now we have to add 700 to 160 to get what? 860, which equals our y. So, for this, instead of writing it as an ordered pair, like we have been, because it's a word problem, in how many months will the cost be the same? We have to answer that question. How many months will the cost be the same?
10 months.
10 months. So that's part of our answer. Because remember here, word problems, we need to do more than just write an ordered pair. We have to answer these questions. And what will that cost be? $860. So this is our answer for that. See how we both have, we still had our x and our y. Yeah, but we have labels with it as well, right? We didn't just say 10, 860. We said 10 months, $860. Questions on that one? Okay, what did you say? It's close to a year? It is pretty close to a year. Okay, so we're going to go ahead. Could we have also solved this with elimination? Yes, would we have gotten the same answer? I sure hope so. As long as we did it correctly, we would have. Let's look at number 3 here, okay? Let's look at number 3 here. And what we're going to do is we're going to work on setting it up and not solving. And then the same with number 4. We're going to work on setting up and not solving because that's gonna give you guys some more work time to work on setting up and solving on your own. Okay, so this kind of move that around. So in number 3, Sam spent $24.75 to buy 12 flowers for his mom. Aw, how nice. The banquet, the bouquet, the bouquet of flowers contained roses and daisies. Roses are $2.50 each, and daisies are $1.75 each. How many of each flower did Sam buy? Well, first my takeaway is flowers are expensive. But how many flowers? How many of each type did Sam buy? So we need to write a system of equations for this, and we're going to use R for the number of roses and D for the number of daisies. So R and D are kind of like our X and Y here, right? They're our variables. So for our first system, you can just think of this as our R column, our D column, and our total cost column. So it's kind of so if we have our R and our D, what term is this going to be?
T.
X and Y.
Y.
It's going to be our constant. We already have our variables in these first two, so we're going to have our constant here because we don't want 3 variables. We want 3 variables. That's kind of a tricky question there.
When we write it out, what do we put that as?
We'll put it as whatever number it might be at that point. So at first, we'll say, okay, the total money was $24.75, right?
Oh, I got it. Never mind.
The total money was $24.75, right?
Yeah.
So where is this number $24.75 gonna go? In the total spot. $24.75.
Not for that one.
Oh. You guys told me, yeah. Okay. Where should it go?
Oh.
The cost of flowers one, right? Okay. You guys are all on top of it. Awesome. So then what would I put somewhere else? Can somebody help me fill in another box here? Great, help me fill in one other box. The total flowers is 12. So for number of flowers, we're gonna put the total as 12 there, right? We're told Sam spent a total of $24.75 to buy 12 flowers. Watch them how we got those two numbers in those two boxes right now. Very important setup right now. Okay? Can somebody help me fill in another box? The cost of flowers, okay? Help me fill in the cost of flowers, Graydon. Okay, $2.50 each. So I'm gonna put $2.50 what? R. We could put X, but in here we're just calling it R. So $2.50 and our variable for roses. Because every single rose will be $2.50, right? Not that if you buy 3 roses, you still only pay a total of $2.50. No, you pay 3 times that number. Okay. What about the cost of the daisies? How could we write that one, Sam? 175D. Very good. Now, what would these two costs be doing? The 250R and the 175D? They'll be adding to each other. You're going to add up your costs. You're going to take however much. You'll already be multiplying the 250 times the number of roses and the 175 times the number of daisies. You'll be adding the total cost. Because what this is saying is, this is the cost of all the roses, this is the cost of all the daisies, added together, and it will equal your total cost. Betsy, help me fill in another box. How do we know how many roses we're gonna get? What's that gonna be? Just R. It's just our number of roses. Josh, what would be our number of daisies? Do we know the exact number? No. What did we do with the roses? Yeah, we'll just call it D, okay? We don't know the exact number, but D is our placeholder for the number of daisies. And what would this R and D be doing with 12? What signs would we put in here? R and D are adding. You add the number of rows and the number of daisies. And it equals 12. The total number of these equals 12. So we have our two equations. And if we rewrote it right below here, in our more equation fashion, we might have this. R plus D equals 12 is our first equation. And our second equation would be 250R, or 2.5R, plus 1.75D is equal 24.75. Questions on how we got that. Questions on how we got to this point. Very important concept of how we set this up. Do we know how to solve these systems from here?
Yeah.
Yeah, I think so. Could we have done this without a table? Yeah, we could have. Did the table help anybody? Kind of organize your thoughts. Okay, it helped a few people. It's okay if it didn't help you. It's okay if it did. Either way is awesome. It's just this can be a tool to help you if you want. So if it helps you, make a table. If it doesn't, don't. Okay, if it helps you not to use the table, just don't use the table. Let's look at setting up number 4. Okay, we're not going to finish solving 3. Let's look at setting up number 4. Actually, what I want is for you guys to work on setting up 4. I want you guys to set up 4 on your own. Don't solve it, just set up 4. Set up our equation on 4. And when you do, or when you have a question, raise your hand, and Mrs. Haswell and I will come around and check it. What was that? Just set it up. So once again, as you set up your equation or have questions, raise your hand. Either when you're done or have questions, and we'll come around and check it.
No, I was trying to-
Then, actually, I want you to set that equation first.
Set it up or like.
We're just not doing nothing, we're setting up. There you go.
Where'd you get that lanyard?
Looks good. This
So
one?
cute, yeah.
Oh, hey, you know, I just found it on the floor one day.
One we bought it.
Crazy, dude.
You know, sometimes it just be like that.
Is it right?
That's one of them.
Skirt. Cool vibes save lives. Is your skirt getting better?
Alright, so let's look at this first one. 2x.
It's getting a lot better. Is he gonna even go down that?
They take it back.
It's straight out.
Do you like
You're the first one, not quite your second one. Also, are these both x's?
Is the color gonna go away?
Well, not quite, so.
You probably need like one more.
It's chicken bruised. I don't think it's chicken bruised. To be honest, like last soccer, I don't think chicken bruised.
So in this one, x is b, the y is b, right?
Squirted back at her.
She filled it with
And
like
then let's-
pepper. Just like, we get
Did you cry?
bruised. Last time it didn't really hurt that bad. Like the first one was the worst. I really feel the other one was kind of just like,
It's like the most satisfying thing is for it to come.
This good stuff. You guys are checked yet? You haven't checked yet. You're checked yet. Haven't checked yet. You just do you just say there's a guy there?
Cause I thought it was your dad and I was like, your dad's way shorter than that.
Yeah, that's not my dad. Yeah, he's a teacher. He's upstairs. I wasn't gonna embarrass him. You're gonna be nice.
I think I got it, Mr. Charles. Better go down.
Wait, no, Mr.
Yep. Yeah, I would
Where am
probably.
I gonna go?
I would probably make it the x plus 2y is 2 all the way, so that's okay. 11.2.
If it was like a market, I think we probably
Yeah,
could
I'd like-
anyway,
Thank
but they
you.
really do not even give two craps that Jay makes anyway.
You just say you're right.
Yeah, he was like, you're wrestling.
Your wrestling skills, when you're really like
And he's like, I should have spent like 135, coach. Yeah.
Usually they
I did some
weigh in
cutting
like
on
after
the
practice. They get the lowest. You're like 220. What are you weighing? 6.
I wrestled some
Yeah,
pure
mine's
one.
106.
That'd be awesome.
He's
No, watch.
Did he ask him how much he weighed?
Okay. Devin, give me your first equation. Hey guys, listen up. Devin's talking. Sorry, go ahead, Devin. 2a plus 3y equals 134. Okay. Peyton, explain where the 2a comes from. Adult tickets is the A. And where does the 2 come from? You bought 2 adult tickets, so 2 of the adult tickets. Yeah, yeah, so 2 of the adult ticket price, specifically. Blake, where does the 3y come from? The 3 youth tickets, y will be the cost of the youth ticket. Where does 134 come from here, William? The total cost that Bree's family spent. Or Brianna's family spent. Brianna, I never know how to pronounce these names. It's always like an either or, right? However they want it. Anyway. So, I swear. So anyway, somebody give me the second equation here. Justin?
146.
Yeah, let's make it match this one, okay?
Okay. 3a plus 2y equals 146.
3a plus 2y equals 146. So here we have 3 adult tickets that Max's family bought, 3 adult tickets, and 2 youth tickets. So we take 3 times the cost of the adult ticket, 2 times the cost of the youth ticket, and set it up to the total they paid is 146. Questions on setting this one up? Once this is set up, do we know how to solve these? Yeah, is this one particularly set up for either substitution or elimination right away? No. Okay, we have to solve either way. Because whether we're doing elimination or substitution, we have to do some manipulation of the equation. If we're doing elimination, we can multiply these equations to get it there. Or if we're doing substitution, we can manipulate one equation to solve for a variable. Questions on that, class? Okay, so what we're going to do is we're going to move on to the homework for this. Homework for this. What did you say, Ben? Or sorry, what did you say, Blake? I was thinking Ben's gone, so I don't advise somebody to pass me one as I said your name.
What do we learn in
Chapter 7, we'll be learning a lot about exponents. So we'll be doing a lot of exponents. Did you ask me if it's easy?
No, I was like,
Oh, yeah.
exponents.
Are we doing something that
Come on,
goes wrong with
reach,
your
boy, reach.
Not really. Hey, you might want to look up here on the board for some instructions, right? So here are some don't do's. So don't do number 4 and 7 through 9. Don't do numbers 4 and 7 through 9. Yes. Hey, and I want you guys, I want you guys to work in partners for this. Okay, I want you guys to work in partners for this. I want you to work in partners. Not can, I want you to work in partners for this. Okay, so please work in partners with this. Okay, we'll be working for probably about 25 minutes. Okay, let's plan on working about 25 minutes and improving with about 8 minutes left in class. Okay, so I want you to partner up. If you don't have a partner, I'll put you with a partner. Okay, go ahead.
I'm drinking my juice pouch.
It's great. Go ahead. It's charity.
Hey, make sure we're working though, and we're not in groups of 4.
Then we do it together.